Okay. All right. Good morning again. It's the third episode of our podcast. I'm Roberto, joined by Rahul. We're the co-founders of Flowlly, an AI platform for construction. And today we're going to be talking about data,
Mhm.
data, data strategies, what it means to need to have data for AI. When do we really need to have data for AI, and what should we do about data?
Hmm.
Because I think data is one of those topics that come up when people start digging deeper into AI. It's
Mhm.
always you need to have clean data. You have to have your data ready for the AI to be able to do what you want it to do. But there are a lot of nuances to that point. So we will talk about those things. Anything else do you want to add to start with, Raul?
Yeah, and then strategy, how we can get ready because AI is progressing, but um, we will see a lot more gain in the future. And so now, what strategies that we should put in place so in the future we are ready for leveraging that data for our work.
Yeah, definitely. So maybe before we talk about data, let's talk about the two type of AIs
Mm.
that we could be using, right? Because that will define really what we think about data.
Mm-hmm.
So on one hand, we have generative AI, which is the AI that we are mostly hearing about today, right? Is the
Right.
ChatGPT is the one that writes and create images and videos and those things. So that's
Yeah.
generative AI. On the other side, we have the predictive analytics type, the right, the one that it's using a lot of data to try to predict something. And
Right.
it's not that they're separate because this second one is kind of the one that it's enabling generative AI.
Mm-hmm.
Like to be able to get to ChatGPT, they had to use a lot of data to train those models, so then they can predict what's gonna come after, right?
Right.
So
Right.
really, in the end, AI it's really a predictive machine.
Right.
It's an algorithm that's trying to predict what's gonna come after, depending on certain parameters, certain
Right.
input, right? So that's all there is. So for generative AI, what is the data you might need
Mm-hmm.
if you're just going that AI path?
All right. So it depends task to task. To build a generative model, you need every knowledge out there, right? So generative knowledge, and we are talking specifically about large language model. These are the models that enables ChatGPT kind of interaction where you talk to it, you put your chat in, and it responds, and it feels like a human is talking to you. So that's a language kind of model, large language model. To train them, basically every piece of knowledge out there on the internet that has been scrapped and has been built into it to make it possible. Now, when it comes to a construction company, what we can do specifically is we can fine tune this model. So, what does fine tuning mean? Is you have a specific way you do things. Your bets are written in a very specific language. When you write work plans, you write in a specific language. You have your own style of doing things. You know that section 2 comes after section 1. So there are certain structures that you follow and certain way you do things, right? It's very generic, very out there, but this is how you do things. So we can take this large language model that has been trained on everything out there and you can make it your own. And the way to make it your own is you need your company's data to fine tune it. So the process that you are doing is you're not building a new model. 99.99999% time you're fine tuning it. Fine tuning means making your own. So that depends on what kind of work you want this model to do, right? Uh, Maybe you have hundreds and hundreds of work plan and you want it to write a new work plan based on that work plan that you have done previously. So you will fine tune this model on all of your previous work plan. Or you are a company who write specification documents for a construction project, and you have written so many specifications before. You have every kind of specifications available in your cloud, right? And now what you want is, instead of people writing all the language, everything, you can fine tune this model on how to write specification. And so when you give it instruction, it will write the specifications for you. So that's what the generative model means, right? Another example could be, you have an architectural firm, right? And you have created so many renderings and designs of like how you envision things. So now you can take those design and fine tune an existing image model and create your own style out of that, right? So that's what I forgot your question.
But so you're talking about fine tuning or kind of training parts of the model, right?
Yeah,
But some of those same outputs can be generated just by prompting.
yeah.
So when would you decide to do fine tuning versus just prompting?
There's a lot of people are trying to figure it out, and from my research and what building Flowlly and like listening to other people, there's like no definite answer to this question. Like there's not an exact parameter that we can follow. Is like, hey, if you need to do this, maybe you should do fine tune or do this. The It mostly depends on what kind of task you are trying to do. And I think the rule of thumb, especially in our world, right, the construction, the kind of task that we are trying to do, the rule of thumb is, you try with prompting first, make it work, and if it works, then you can see like what is the benefit of fine tuning. Maybe it's cost. Like if you're doing some work over and over and over and again, your firm specializes in one kind of work, and you want to fine tune the LLM in that particular work, then it's probably necessary to fine tune the model according to that. But the rule of thumb is, try with prompting, see if you can make it work, and then see the cost analysis, and then you go for fine tuning the model.
Yeah.
Prompting first, then. So it's like hit and try,
Mm.
see if it can work, right? Yeah.
Yeah. Yeah, and also because for fine tuning, ideally you need a lot of data, right?
Yeah.
Because what the model is going to try to do when you fine tune is find patterns in your data to then go and replicate those
Yeah.
patterns.
Yeah.
So if you're only giving it two examples, then it doesn't have enough patterns to do something real, right? Like you need a lot of examples to be able to give it. So either if you don't have all those things structured, then it's going to be difficult to get a good fine-tuned model. Yes,
Yeah.
you might be able to fine-tune something,
Yeah.
but it's not going to be good enough.
Yeah.
With prompting, you don't need that, right? With prompting, it's pretty much just writing a recipe for it that it's going to follow, and and so you don't really need to be giving more than one example or a couple of examples,
Yeah.
right? So that's the difference. So if you want to fine tune, which potentially would give you a better result, and sometimes even find things that you don't know, because it's going to
Yeah.
go through a lot of data and it's probably going to find patterns that you haven't seen, but that means having a lot of data. If
Yeah.
not, prompting is the way to go. Like you said, maybe starting with prompting also to figure out what is it really that you need the AI to do,
Mhm.
and what type of data you would need for it to do that, right?
Yeah.
Um,
And you've been playing a lot of with prompts and trying to do things with the prompts. So I think the concern that is in knowing, from coming from like, we know a little bit about how to build this product and stuff, the consistency. So can, with the right prompt, do you think we can achieve really good consistency, a good result after another, or like the way I want my document or my response of the LLMs to look like every time I do this, it's just gonna look same if we do have really good prompt. What do you think?
I I think we're still not there. I think there's always some randomness that
Mm.
happens that you can't really control. You
Yeah,
can try writing an amazing prompt, but still the AI is gonna do something that you were not expecting in
right.
1% of the cases, or I don't know the numbers, right? It's not every output is completely different, but yeah, there's some nuanced differences
Yeah,
at the end. With training a model, you won't get those things ideally, right?
yeah.
But I think at this point we're still talking about generative AI, right? So it's
Hmm.
fine tuning a writing model, fine tuning
Yeah.
an image generation model. But then there's the whole other side of just doing machine learning
Hmm.
to predict something, right? So
Yeah.
you have a long database of whatever, maybe product pricing or something, right? And you want to be able to predict maybe how the price of X material is gonna go depending on weather, supply, whatever fields you have in your database, right?
Yeah.
So AI or machine learning is a good way to do that, right? It's
Yeah.
give it all the data. Again, it's gonna try to find patterns, and it's just gonna give you a a probability of something happening, right?
Yeah.
Probability of price increasing, probability of price decreasing. This is something that it's used a lot in maintenance, right? So
Hmm.
machine maintenance. So it's ingesting a lot of data all the time, and they already have a, what an algorithm, let's say, that it's taking all the data, processing it, and then it's finding that probability, right? And
Hmm.
as long as the probability is lower than a threshold, then it's fine. But as soon as something happens that make it go up, then it may be time to look at that machine.
Right.
And that's not generative AI. That's just another type of machine learning AI that it's just based on all the data that it was used for building that algorithm. Now, every time a new data comes in, it puts it through that mathematical model to come up with a number, right?
Right.
For that one, where do you see that one playing in construction?
That's a good question. So the machine learning is a bigger umbrella, and there are like various techniques and methods and kind of systems that we can develop. Large language models are the one, and we have other kind of AIs. For everything is a predictive machine, so it's predicting next thing, right? So for large language model, it's predicting what is the next word, or the even like what is the next font or text that's going to be there, right? For images, it's pixel. What is the next pixel that's going to be there? The same pattern we can use in many different ways, right? For construction, let's say you have a fleet of equipments and you have like a large fleets, there are thousands of equipments and you have to maintain those equipment. It is very crucial for you to know when the equipment is going to break, right? Or you need maintenance for those equipment. So you can take past historical data when you have um, done maintenance on that equipment. What is the life of that equipment? What are the parts that you have installed them? What kind of jobs you have used that equipment in? Who are the operators? So every possible parameters about that equipment, you can take those if you have that data, and then you can build out a model that will essentially tell you, okay, this equipment, I think this equipment is going to break down in next couple of months, and you have installed on very crucial job, then it essentially depend on this equipment performing. So maybe you should send out a mechanic to look at it, or maybe you should do service and repair for it. So that's really one really good example where this kind of predictive analysis can be done, right? Um, so that's from maintenance perspective. uh, you need very structural data. You need to have large fleets of equipment to do that, right? Then only it makes sense. And we have seen examples of the construction companies deploying that kind of techniques way in the field, right? Other example is you could forecast. So maybe you need to buy more materials or equipment based on the jobs that you are going to get, but you have past historical data. So you can prepare for those kind of things, right? You can forecast, hey, maybe I need to buy etch still now, because this is going to be, we will need that a lot in my jobs, right? So
Yeah.
you can forecast your requirements based on that. You can, so forecasting could be anything: your employee forecast, talent forecast, your equipment forecast, um, those kind of things, and you can build really good models that can do those things for you, right?
Do you think it could also help with schedules?
It can, definitely it can. We already have tools in the market that are enabling those kind of things. If you have your past schedules, it you have your past patterns and how you are doing things. If you have a large enough database, because schedules are very dynamic, there are a lot of variables. It's who are the people working on the job site, what kind of job site it is, what is the temperature variation, what is the weather variation look like, what kind of ground we have that we are working in, what is the global forecast of like the inventory, right? Steel prices and all those things. So everything becomes really, really important part of the schedule. Even like cities, laws and codes and bylaws, they affect your schedule. Like some, if you are trying to get a pull a permit and the city's bylaws, or even like the people who are approving are the different, then it's going to probably affect your schedule. So but that's what the job of the manager is, to look at all these parameters and build out enough flow in your schedule so you can do those things properly, right?
Yeah. Yeah. So I think really the first step
Yeah,
is try to document as much as you can, right? Gather as much data as you can, like use sensors when you can, uh, leverage tools like daily logs, all those things, right? That
yeah,
many construction companies are already doing, and more should be doing and using those tools, because the way the technology is evolving, this is just going to be more and more important.
yeah,
Having the data is going to be important, and in the beginning, yes, if you can start structuring it better,
yeah,
but it's first just gathering the data, right? Because
yeah,
going back to the schedule, like you said, there's all this parallel data that it's happening, right? That it's
yeah,
not just a schedule. The schedule is maybe one point in the data set,
yeah,
right? But why something got delayed, right? If you're looking just at the schedule, you might not have the data there. You just know that this thing was supposed to start on this date, but now it's starting on a different date. But
yeah,
if you look at maybe the daily logs, you there have some clue of what happened, right? The
yeah,
material did not arrive. Then you have to go and look at what was said by the company sending you the materials, right? Maybe, like you said, the prices of the materials went up, or there was a disruption to the supply chain. Something happened, right? So it's not just a one point that it's going to give you the answer. Now you need to find a way to connect those things, and that's where really these machine learning models, when we talk about patterns, that's what they see, right? Like,
yeah,
if you give it all this data, even though for you might not have a direct connection, it will be able to find the connections for you, right?
yeah,
But that means you have to have a schedule, you have to have the daily logs, you have to have maybe all the conversations with the suppliers, weather data, like different data. And I know
Yeah.
it's overwhelming, right? Like, where do you get started even, or
Yeah.
where are you putting all the data, right?
Yeah.
So it's not an easy thing to do,
Yeah.
but the more you can gather all that, then the
Yeah.
better it's going to become at one point for you, right?
Yeah. And
Uh,
construction is a funny business because like construction folks, they gather lots and lots of data and then dump it. They never use it, right? And so this is like very good opportunity at the cross section. Like when we talk about this generative AI kind of technologies, and then this predictive analysis or predictive forecast kind of technology, when we merge this two, the magic happens, right? Because all the construction companies, they, like the good ones at least, they are very good on collecting these daily reports. Their supers are doing really nice daily logs. They are they are looking at their schedules, updating their schedules, so they have their history of the schedule updates, and basically from those you can find out like what it was reason for updates. The NCRs, you have like NCRs, so you know like what fell when, the safety reports. So if you take all this data, and now there's language model, which is basically can understand language, you can tell it, hey, I want like why this equipment fell, give me those reasons, and build it into a table. It can do that, right?
yeah,
So now you take this technology and create this very structured data, then you can enable this forecasting with this existing data collection method.
yeah,
So now for construction companies, it becomes really, really, really important that they collect every kind of data, and they do a really meticulous job of it now. Um, Not necessarily like I want to structure in this way, but
yeah,
just collect it. Yeah.
yeah. So collecting data from meetings, collecting daily logs, sensors on equipment, pricing, all those things become really, really, really important. Everything related to schedule, right? Because that's where the picture of what's happening in the project kind of comes together,
Right.
right? That ideally that's the schedule. So
Yeah.
the more you can incorporate that schedule, the better
Yeah.
at some point. And like you said, now you don't it before we would have to be thinking how are we going to structure this data, right? Because
Yeah.
these machine learning models, yes, they're only consuming from tables,
Yeah.
right? So the data has to be structured, and that was difficult because it required a lot of thinking. Now this generative AI, it can generate those tables for us from unstructured data.
Yeah.
By unstructured data means audio, video, just long text documents, right? That it's not a table with columns and rows. It's
Yeah.
data that looks nothing like a table. And so it can take all that and put it into that structured table. So now we don't need to be worrying that much about how the structure is going to happen because we can use AI for that. But still, the gathering of the data is what's really important. So yes, gathering the data. But something people say about construction is almost every construction project is unique, right?
Mm.
It's not like a factory where you're making the same thing over and over and over and over. So it's easier to predict things in that place, right?
Yeah.
When everything is different, just because weather is changing all the time, right? So something you built 5 years ago, the weather is completely different now after 5 years, right? So how do you incorporate that thinking into this concept of data for making predictions?
Yeah. I mean, so a lot of things are different, but a lot of things are very similar. You have fleet of equipment, and if they are running on the diesel, then they're gonna consume diesel. They'll they'll You'll need to buy diesel. It's like fact, right? And then if you need to forecast like across this region how much diesel I should buy, then probably you should look like age of the equipment and how much they've been using in the past, so you can predict in the future. So that's like very, very clear cut example that's like uniform across the board. So the the challenge is to finding those uniform things that you want to search in those things, and what you want to do, right? And so uh, yes, the project is different, but it's also very similar in the sense, like, it's very different, it's within the boundary. So still there's a boundary around it, and the differences, there are differences, but they are within those boundary. Even the folks who are working on the one project, they get moved on to next project. So there's also the talent shuffle that's happening, and people are taking and bringing their work and practices, and also, so it is homogenized to a certain extent. So when it comes to data, the obviously you will be building models and forecasting based on your kind of data, but the underlying technique that will work across different kind of projects and different companies. So the same techniques will work for every different company, even though their projects are wildly different or different kind of things. If you want like specific answer you want to get to,
Mhm.
and you have a specific constraint around it, right?
Yeah,
um, yeah.
cool. So we have 4 minutes left. What would be the strategy? Like, if people listening to this are thinking, well, where do I get started, right? Like, we're a construction company. I cool data, yes, but we build buildings, right? So how do we get started? What do we do? What
Yeah,
would be your strategy and advice?
I think the approach has to come from top down. So it's I think responsibilities of the executives and the leaders of the construction industry to emphasize on the importance of data collection, because the gain that we're gonna get from this thing is not an immediate gain. It's not like you negotiated a subcontractor for a lower bid. You won't see immediate gain. The gains that when once you put on the strategies, if you collect the data properly and you make sure that all the data points are collected properly, you'll see those gains in 5, 6, 10 years. So until then you have to build out practices, you have to build out right strategies that you should collect data. And like I said, we are at a cross section where the llms models can take the data, structure it properly, and then you can use and build the forecasting models that will help your business gain more revenue in the future. So step one is you identify like where what if you're not collecting good data on daily basis, just like your regular things. It doesn't have to be anything very complicated. Your minutes of the meeting, good notes on minutes of the meeting, your equipment logs, why your maintenance logs, your safety reports, your audit reports, your quality inspections, your daily reports, your deliveries, uh, everything. And if you have sensors and the previous properties that a property management firm has built, collecting the data around it. So making sure you have that data and then data is accessible. It's not sitting in a project's document and once you leave the project it is in that one. It's like
Yeah,
you have a data sharing strategy between all your different projects and anybody can use that data. So making sure you collecting right data, making sure your guys and your people are doing very good job of collecting data, and then everybody you have a sharing policy across the project. So you can share project data. That's like step one. It's A of the alphabet. And so once you have done that, then you can do more things. But if that's broken, then nothing is going to work.
yeah, makes sense. So I guess it's, if anything, you guys should take from this is, as long as AI is around, data is what makes AI work, right?
Yeah,
What makes AI happen. And so having data, as a few years ago, there was this headline that was saying data is the new oil,
yeah,
right? So it's the data is what's going to make these things function. So the better you are at gathering data, and the earlier you start gathering as much data as you can, then the better position you're going to be. And like you
Yeah.
said, it's maybe you're not going to be seeing the results tomorrow, right? It's a long-term game here,
Yeah.
but it's one that it's going to pay off,
Yeah.
right? So it's not something that, oh no, it's never going to be used. No. The more this AIs evolve, the more data becomes important, right?
Yeah.
And now we're getting to the point where apparently these things have consumed all the data that's publicly available, right?
Right.
And so now it's becoming a matter of where else can the data come from? And
Right.
now if you have your own data, that's your competitive advantage, right? Because
Right.
now these models are going to have like a set level based
Yeah.
on all the data that's available. What's going to make them different is your own data.
Yeah.
So the better you are at having that, the better or more value you're going to be getting from these AIs.
Yeah.
So start thinking about data, gather as much data as you can, push your teams to be doing all those documentation that Rahul mentioned, right? Make sure they're capturing the data. And there are many ways in which they can do that, right? Like we
Yeah.
said, it doesn't have to be super structured. It can be voice notes, it can be videos, it can be images. But make sure you're gathering those things so then you can put them to good use when you need to use it
Yeah.
for training models.
Yeah. So step one, collect data. Step two, ask yourself question like what are the things you want to know or you
Yeah.
want to forecast, right? If you have good questions, then the answer is in the data.
Yeah.
So step two is figure out what are the good questions that you want answers to.
Yeah.
That's also very difficult. Yeah.
Exactly. All right. Well, it was nice chatting again, and we'll see everyone next week.
All right.
Have a
Talk
good
to you guys. Bye
week.
bye.
Bye.